All right, we're here to talk about the triangle inequality. Triangle inequality. Let's define the terms first. Triangle is a polygon with 3 sides. The sides are made up of line segments. Inequality is an expression that it has a less than or a greater than, or a less than or equal to, or a greater than or equal to involved in it, right? So inequalities that involve triangles. The simplest way to talk about the triangle inequality is to draw 3 points on the screen. I'm going to label them A and B and C. Okay? And I'm going to ask this question. I have a goal. I would like to get from point A to point B. Would it be quicker for me to go straight from A to B in this straight line, or to go to point C first and then go from point C to point B? Okay. Hopefully intuitively you have the answer already in your head. The shortest distance between A and B is to go in a straight line. So this is, in fact, one of the ways we can state the triangle inequality, though it's not in a formal manner, that the shortest distance between any 2 points is a straight line. Formally, here's how we write the triangle inequality. We write it that AC plus CB, that is, if I go from A to C and then C to B, that has got to be longer than going straight from A to B. So for example, if AC is 8 and CB is 4 and AB is 19, we know we have a problem, because 8 plus 4 is 12, which is less than 19. It's not more than 19. And we have created a situation where going something other than a straight line is shorter than going in a straight line. But we intuitively understand that to go in a straight line is the fastest way to get there. So any 2 sides is going to be more than the third side. We can also state this way. AC plus CB is greater than AB. We can say AB plus BC is greater than AC. And we can also say that AC, or CA or AC plus AB is greater than BC. Okay, any 2 sides are going to be greater than the third side. Now, there's several ways that you can be asked questions involving this triangle inequality. Now, let's go over a couple of them here. Number 1, you might be asked, if you were given 2 sides, or given 3 sides, okay, 8, 7, and 3, does that form a valid triangle? Does that break some rule about the triangle inequality? To find out, take the 2 smallest sides, in this case 7 and 3, and add them together. And they should add to more than the third side. In this case, the answer is yes. They do form a valid triangle. Let's say I've got these 3 sides, 2, 19, and 8. Okay? Take the 2 smallest sides, 2 and 8, and add them together. Is 10 more than 19? And the answer is no. So this is not a valid triangle. Okay? So if the 2 smallest sides don't add to more than the third side, you know you don't have a valid triangle. Okay? Here's another way to ask, that we could ask this question. If you were given 2 sides, say 3 and 8, okay, what is the valid range of points that the third side could be? What can the third side, let's call it x, equal? So given one side is 3 and one side is 8, what can the third side equal? Well, in order to answer that question here, let's lay them out end to end. So I'm going to lay out a segment that's 3, and 2, 4, 6, 8, a segment that's 8. Okay, and I'm going to lay them end to end. What is 3 and 8 combined? 3 and 8 combined is 3 and 8, 11, right? So now imagine I take my compass here and I'm going to draw. I'm going to change the angle. I'm going to bend the angle right here where they join, just ever so slightly. I'm going to come up with that end. I'm going to raise it up to about here, and I'm going to form a triangle. Okay. So here we go. Triangle. There we go. So now it forms a valid triangle, but by doing that, what have I done to the side 11, the distance between the end of the two segments? I've made it a little bit smaller, so this is less than 11, right? So x, the third side, has to be less than 11. It can't be greater than 11. It has to be less than 11. Likewise, let's consider laying them not end to end, but overlapping. So I'm going to put my 8 segment here, 2, 4, 6. Let's see, 2, 4, 6, 8. Okay, for the whole thing, right? So this is 8, and this is going to be 3. Okay, overlapping. What is the difference between 3 and 8, or what is the length of this segment? 8 minus 3 is 5. 8 minus 3 is 5. Now again, those are collinear points, so they don't form a triangle, but imagine, if you will, again, I've got this situation here where I take the right side of the 3 segment, use my compass here to draw it, and I lift it up like opening a gate here, just a little bit, so that it comes up a little bit. What have I done to that 5 segment here? Have I made it shorter, or have I made it longer? Okay, have I made it shorter, or have I made it longer? Hopefully you'll understand by raising that side up, so it's still 3 long here, that I have made the 5 side bigger. So this is bigger than 5. So x is less than 11, but it's also bigger than 5. Okay? So let's interpret that in simpler forms here. Let's answer a question here. If we're given 2 sides, 9 and 17, okay, then the third side can be between, on the low end, 17 minus 9, and on the upper end, 17 plus 9. 17 minus 9 is 8, and 17 plus 9 is 26. Okay? And so x, our third side, has to be between 8 and 26. So it has to be between the sum and the difference. All right, there's one more kind of question in this unit, or in this lesson. And this one can be a little involved. It involves solving inequalities in geometry or in algebra. So you'll have to recall some of your algebra steps. If you're having difficulty remembering your algebra, feel free to book a live lesson with me. I'd be happy to go over some of the basic skills with you. I will try to explain each step as I go to hopefully bring to your memory how to solve inequalities. But the case is this. We have a triangle in which we've labeled the 3 sides of the triangle with lengths that are algebraic expressions on x. So one side is 2x plus 5, another is x plus 1, another is 5x minus 6. And we use the inequality, the triangle inequality, to limit what x can possibly be. So that's the goal. We want to find out what values x can take to make this a valid triangle. right? So the triangle inequality says, again, that any two sides are going to be more than the third. So I'm going to take the top two sides, 2x plus 5 plus x plus 1. So the top two sides are more than the bottom side, 5x minus 6. Okay? So the top two sides are more than the bottom side. And I'm going to solve this inequality. Right? You may recall there's a step called regrouping or combining like terms. We have 2x and 1x. When we combine those, we get 3x. And we can combine 5 and 1. When we combine those, 5 and 1 make 6. Greater than 5x minus 6. Okay, now we've got an x on both sides of the inequality. We get rid of one of them. Now there's no rule about which one you want to get rid of, but I'm going to get rid of the smaller one because I like positive numbers instead of negative. So 3 is smaller than 5, so I'm going to subtract 3x from both sides. Anything you do to one side, you do to the other. All right? And likewise, I'm going to do the opposite of minus 6. I'm going to add 6 to both sides to eliminate that minus 6. And here's what happens when you do that. We get 3x minus 3x, which is 0x. We get 6 plus 6, which is 12. We get 5x minus 3x, which is 2x. And we get negative 6 plus 6, which is 0. So we just eliminated the extra x's and the extra constants. Now we want to divide, because the opposite of multiply 2x is divide 2x. I'm going to divide both sides by 2. Anything you do to one side, you do to the other. Okay, and so x, this is read from the x side, x is less than 6, or you can flip it over, but when you flip it over, you've got to flip the inequality. So the greater than switches to a less than. X is less than 6. All right. So that's solving that inequality. But remember, there's 3 inequalities with any equation. So let's take the right side, the x plus 1 and the 5x minus 6. So x plus 1 plus 5x minus 6. Those two sides have to be greater than the third side, 2x plus 5. And so let's go through the steps again. Let's combine like terms. 1x and 5x makes 6x. And 1 and negative 6 together make negative 5. So we've got 6x minus 5 is greater than 2x plus 5. And now I think I want to get rid of one of the extra x's. 2x is smaller than 6x. I'm going to subtract 2x from both sides. And I'm going to add 5 to both sides to eliminate the minus 5. Okay. And 6x minus 2x is 4x. Negative 5 plus 5 is 0. That's as intended. 2x minus 2x is 0. Boy, I can't seem to draw an inequality symbol. There we go. And 5 and 5 is 10. Now we want to get rid of the 4 by doing the opposite of times 4, which is divide 4. And 10 divided by 4 is 2.5. Okay. All right, we've got one more inequality because we can write 3 inequalities with one triangle. I'm going to take the left side in the bottom. So 2x plus 5 plus 5x minus 6 is greater than the third side, x plus 1. Okay, combine like terms. 2x and 5x are 7x. 5 and negative 6 combine to make negative 1. Okay, that's called regrouping or combining like terms. 2x and 5x are 7x. 5 and negative 6 is negative 1, greater than x plus 1. Okay, and I need to get rid of the extra x. 1x is less than 7x. I'm going to take away 1x from both sides. And I'm going to add 1 to both sides. Okay? And we end up with 7x minus 1x is 6x. Negative 1 and 1 is 0. 1x minus 1x is no x's. 1 and 1 is 2. We need to get rid of the 6. We get rid of the 6 by doing the opposite. We divide 6. Okay, and we get x is greater than 1/3. Okay, now what does all this mean? We have 3 inequalities, 3 expressions for x. What values can x take that would satisfy all 3? Well, what I'm going to do is I'm going to make a number line. So I'm going to make a number line starting at 0 and going up to 6. I'm going to do it this way. 1, 2, 3, 4, 5, 6. Okay, and we're going to graph each of the 3 inequalities above the same number line and look for overlapping parts. There we go. Look for overlapping parts. So here we go. Let's see. The first inequality is x is less than 6. Okay. So I'm going to put a circle above the 6. And I'm going to draw an arrow or a ray pointing to the left from 6. Because less is left. Left is less. Okay, that's x is less than 6. Okay, and then I'm going to graph x is greater than 2.5. So 2.5 is right here. And greater than is right. Greater than is right. Less is left. Greater than is right. Okay. And this is x is greater than 2.5. And then we've got the last inequality, x is greater than 1/3. 1/3 is about here. And greater than is right. Okay, here we go. So these three are these are the 3 separate inequalities that we solved for. X must satisfy all of these at the same time. So we look for the overlapping part. What part of the graph is graphed in all 3? And it seems to be from 2.5 up to 6. That is the overlapping part of all 3. And so our inequality for x can be simplified to just this one. X must be between 2.5 and 6. Okay, hopefully that makes sense. I know that's quite involved. Feel free to book a live lesson if you want help practicing this.